Solving systems practice and number of solutions. So in this lesson, was just mostly practice of solving systems and kind of differentiating between when to use elimination and when to use substitution, because it's generally going to be a choice up to you of how you solve them. But there are some special cases to where there might be infinitely many solutions or no solution. So here are a couple examples. Let me just talk through them really fast. So let's say example 1. Right? You have 6x minus 2y equals 8, and you have y equals 3x minus 4. So what you would do on this one, most likely your approach, would be to take this and substitute it in for y. So you take that, substitute in for y, and then you have this, 3x minus 4. That's in for y there, right? And then you distribute and, all that good stuff. You get 6x plus 8. And then this is the interesting thing. And let me highlight this in pink. 6x minus 6x. So you begin to combine like terms, and this is where the special case happens. Those x's cancel each other out. They disappear. 6x minus 6x is 0x. It's nothing, 0. And then you don't even have a variable to solve for. You just have this statement that says 8 equals 8. Well, if this ever happens to you when you solve and you get this, the variable eliminates and you get this statement that's, I'm going to call this is a true statement. This is an equality. This is true. We're going to say there's infinitely many solutions. And I could go into a whole spiel of why there's infinitely many solutions, but I'm not going to get into that whole thing right now. There's going to be infinitely many solutions. It actually means that those equations are the same equation. So there's an infinite number of solutions to this. But let's say in example 2, we have a little different case. So let's say you have this. This one's actually better set up for elimination. And you say, okay, I'm going to multiply this equation by -3. From looking at the work, this is what it looks like it did. So you have -6x minus 3y equals -15 after you multiply that by -3. And then you go to eliminate. You're like, okay, all right, I'm going to eliminate now. And then this interesting thing happens. This eliminates, but even the y's eliminate. Both eliminates. That's crazy. So now there's nothing on that side. Again, both variables disappeared, no variables, and then since that side has nothing on it, it's just 0. So it's 0. And then you have this statement that says, -15 plus 19 is 4. You have this statement that says 0 equals 4, which is obviously, I'm gonna label this as this is false if it says 0 equals 4. That's why I wrote not an equality there. It's a false statement. So in this case, we're going to say no solution. Say no solution there. And I could go on a big spiel again as to why it's no solution, but I'm not going to get into all that. So basically what you need to understand, for purpose here, is that if we get an equality, if our variable disappears and we get a true equality, we're going to say there's infinitely many solutions. And if we get something that's false, like if it says 0 equals 4, which is not an equality, we're going to say there's no solutions. And then, so let's just kind of move on here and do some of that math. So here we go. Number 1, solve the following system of equations. One will have no solution. The other one will have infinitely many solutions. So letter A is better set up for elimination because neither of them are solved for a variable. So what I'm going to do is I'm going to maybe try to eliminate the x's here. So that's what I'm going to try to do. I'm going to try to eliminate the x's. So what I'm going to do is I'm going to multiply this. I'm going to multiply this equation by -2 so I can get a -2x. So first, let me just rewrite that first equation. And the second equation is now going to be -2x minus 8y equals, would that be -12? So then this is what happens here. So we try to eliminate the x's, eliminates, but look, the y's also eliminate. So this side just says 0 on it. Now, if we look at the right side, 12 plus -12 is 0. It says 0 equals 0. This is true. That's a true equality. It's true. So we're gonna say this is infinitely many solutions. We stop the problem here, and we can say there's infinitely many solutions to this. Let me show you the second one. Okay, so we have, this one's actually better set up for substitution. We have x equals 2y plus 5, so I can take this and plug this in for x. So I'm going to have 3 2x plus 5 minus 6y equals 11. So I just substituted that 2x plus 5 in there. So distribute 3 times 2 is 6. 3 times 5 is 15. And then watch this. Watch this. Look, we combine like terms. So we would be combining our 6x. Oh, whoops. I accidentally wrote that as an x there. That was, I'm substituting 2y plus 5. So that should be, sorry about that, guys. That should be 6y. Okay. Anywho, 6y and negative 6y, those cancel each other out. They equal 0. So the only thing that's left on this side is 15, and it says equals 11. That doesn't make any sense. That's not a true statement. That's a false statement. Our variables eliminated. So we have 15 equals 11. So we're going to say there are no solutions to this. Again, there's bigger explanations as to why we call infinitely and no solutions. I'm not going to get in all that. You can look that up in different like math texts and stuff. But yeah, infinitely many solutions, no solutions. Okay. All right. So this sort of special case stuff is pretty rare. It doesn't happen very often, but just be careful of it. So that's basically the new thing in this lesson. Is just this infinitely many solutions, no solutions. So it might pop up here and there. So now with the rest of the video, I'm just going to go and do just some normal problems. That's just kind of reviewing the last 2 lessons. So I'm just going to do a few of these. So solve the following system of equations by substitution or elimination. So you get to choose. Write your final answer as an ordered pair. Some solutions may have infinitely and some may have no solutions. So just, it might happen. And it probably won't. It won't happen often, but it just might happen. So I'm just going to start solving a couple. So here we go. The first one, I look at this equation. It looks like it's best set up for substitution because the second equation right here, it's in y equals. It says y equals x minus 5. So if y equals x minus 5, I can take the x minus 5 and substitute it in for y. So I'm going to have 4x plus 2, put in the x minus 5 for y. Equals, equals 14. Distribute the 2. I have 4x plus 2x minus 10 equals 14. I can combine some like terms here. The 4x and the 2x should make 6x. And I'm sorry, I'm going kind of quickly here just because we did practice this in the last couple of lessons. Add 10 to both sides. Divide by 6. We have x equals 4. Still have to get y. Well, y equals x minus 5. So y equals, we got 4 for x. So 4 minus 5 is negative 1. So 4 comma negative 1. So that one got a solution. As I'm saying, oftentimes they're going to have solutions. Okay. Letter B. Let me do B. Now B, you look at it. I always think, okay, can I use substitution on this one? Because I personally like substitution better. And I look at it, and neither equation says x equals or y equals. So I don't think substitution's really we have nothing really to substitute here. Now you could manipulate the equations to make it okay for substitution, but this looks like it's better for elimination. So I need to eliminate one of the variables. So I either eliminate the x or eliminate the y. So my choices are, now don't write this yet. I could multiply the second equation by negative 2. That would have helped me eliminate the x's. Or I could just multiply this first equation by 3, because then I would get a negative 3y here, and that would eliminate with this y as well. So like those are a couple options I could do. But what do I want to do? I'm going to just multiply the first one by 3. So this is going to be a 6x minus 3y equals, that would be negative 57. Rewrite the second equation. Didn't need to manipulate that. The y's will eliminate. This would be 6x plus 1x is 7x. That'd be negative 42. Divide by 7, x is negative 6. Okay, and now we just have to solve for y. So I'm going to use the second equation, the x plus 3y equals 15. So x is negative 6, so I'm going to have negative 6 plus 3y equals 15. I'm going to add 6 to both sides to get rid of that negative 6. It'll be 21. Divide by 3. Y is 7. Ordered pair. Negative 6 comma 7. Okay, so those actually got us real answers. Now, just as a little hint, the next 4, I think a couple of them you're going to have one of these special cases where you have infinite solutions or no solutions. I think that's going to pop up. Okay, so let me just do a couple more word problems. Might as well, if you need help with these. Here's a couple more word problems. So number 3 says Principal Robinson spent $127.50 on bagels and donuts for her staff before a faculty meeting one morning. Bagels cost $1.25 each and donuts cost 80 cents each. She bought 20 more bagels than donuts. Okay, so I'm going to first kind of create a money equation. I'm going to say B are the bagels, D are the donuts. Okay, so it's $1.25 times your number of bagels plus the 80 cents times your number of donuts equals the total cost that it cost Principal Robinson, which was $127.50. Now, the second equation is based off of this statement. She bought 20 more bagels than donuts. 20 more bagels than donuts. So that means the bagels would have to equal the donuts plus 20. So here we go. We have it. So how I'm going to solve this is by substitution, because one of the equations is solved for the variable. It says bagels equals donuts plus 20. So I can take the D plus 20, which is B, and plug it in for B. So I'm going to have 1.25 D plus 20. Let me write that in blue just so it's more clear. Plus 0. I'm just going to write 0.8D equals 127.5. Distribute 1.25D. 1.25 times 20. I think that's 25. Yeah, just making sure. Plus 0.8D. Combine some like terms here. That would be 2.05. Okay, subtract 25 on each side. Would be 102.5. Divide by 2.05. I got 50. Okay. So it looks like bought 50 donuts. Now let's get the bagels. And the bagels are super easy because the bagels are just, I'm going to use that second equation up there. Bagels equals donuts plus 20. So bagels is going to equal, again, we got 50 for the donuts plus 20, 70. So 50, I'm just going to write it out, donuts and 70 bagels. I'll do one more word problem just to help you out here. One more word problem. The Martinez and Aguirre families bought turkey sub sandwiches to bring to the beach. The Martinez family bought 2 half subs and 3 whole subs for $33.35. And the Aguirre family bought 4 half subs and 2 whole subs for $36.50. Write a system of equations like we used to solve for the cost of half subs and the cost of whole subs. Okay, so I'll first write the Martinez family. So 2 half subs. So I'm gonna say H is the cost of a half sub and W is the cost of a whole sub. So 2 times the half subs plus 3 times the whole subs, and their total cost was $33.35. And the Aguirre family was 4 half subs and 2 whole subs. 2 times the number of whole subs would be $36.50. So there's my system. Now I'm going to rewrite that system down here. Okay. And I'm going to try to solve this. So neither equation is written as like an H equals or a W equals. So I can't, this is not set up for substitution. So I'm going to have to use elimination. So I need to eliminate one of the variables. I could eliminate the W's by getting one of them to -6, the other one to +6. But honestly, I think it's going to be easier just to eliminate H because I would only have to manipulate one of the equations. All I'd have to do is multiply this one by -2, and then that would give me -4H, and then I can eliminate the H's. So that's going to be -4H minus 6W. I'm typing that in. Hold on. Times -2. This would be -66.7. I'm going to rewrite the second equation. Set up for elimination. H is gone. Add those down. -4W. Add those down. Type this in. I got -30.2. Divide by -4. And I got 7.55. So I think the whole subs are $7.55. Now let's get the half subs. So I'm going to plug in 7.55 for W. Okay. So I'm going to have 2H. I'm going to do it on the first equation. 3W is 7.55. Three times 7.55 is 22.65. Subtract 22.65 on both sides. 33.35 minus 22.65. I got 10.7. Divide by 2. And H is 535. Okay. So whole subs cost $7.55. And a half subs cost $5.35. So those are just some extra examples. You know, we've done substitution and we've done elimination previously, but this is kind of mixing them both together. So I'll let you do all the rest of the problems.